Hello and welcome to ABB TechTalks webinar, Fuel Cells for Ships, Scaling Up for Wider Commercial Application. My name is Margareta Sjösen from ABB Marine and Port Communications, and I will be your host today. Fuel cells are widely considered as one of the most promising solutions for reducing harmful pollutants. Already today, fuel cells can power ships over short distances, and progress is being made to make this technology capable of powering large ocean-going vessels. Today's Tech Talk session, presented by experts from ABB and Ballard Power Systems, will cover the following topics: fuel cell technology for ships from small to large vessels. We will also address market drivers and discuss how fuel cells compare to other low-carbon solutions for ships. We will look into fuel cell projects in shipping, as well as into taking land-based competence to the high seas. And we will, of course, talk about fuel cell application for various vessel types. Some practicalities before we get started. Please note that this webinar is being recorded, and you will be able to access the recording within the next few days. After the presentations, a Q&A session will follow. If you would like to ask our speakers a question during the presentations, please click on the chat icon at the bottom of the screen and type in your questions in the chat panel that will open on the right-hand side. We will address as many questions as we can during the Q&A session. Today's speakers are from ABB Marine and Ports, it's Stein, Global Product Manager for Energy Storage and Fuel Cells, who is leading business development and R&D efforts on fuel cells and energy storage for ships. From Ballard Power Systems, presenting today will be Dennis Jensen, VP of Technology, who is leading technology developments and bringing innovative products and solutions to the marine market. Also from ABB, it's myself, Margareta Sjösen, and it is my pleasure to be your host today. And with that, let's get started. Stein, over to you.
All right. Thank you, Margareta. Thank you for the introduction. Hope you can all hear me well. Good afternoon to everyone, and I would like to thank everyone for joining. It's great to see so many that have joined us here today. Like Margareta said, I will touch on our activities in fuel cells, talk a little bit about the drivers we see in the market, as well as alternative fuels and how we see this possibly going forward in the future. To start with, just a very short introduction about ABB Marine and Ports. We are a part of the Industry Automation Division in ABB. We are about 800 people globally. Our visions are to focus on electric, digital, and connected vessels. We are present in 26 different countries for both service, sales, and project execution. Our marine solutions cover our propulsion solutions, such as the Azipods, electric solutions, both DC and AC solutions, digital offerings, including automation, power management, as well as advisory systems. And of course, services is an important part of our solutions. We are in business in many different vessel segments, ice-going vessels as an example, passenger vessels, oil and gas vessels, cargo vessels, and a big range of passenger vessels from small vessels to the larger passenger vessels. When we look at zero-emission operation and the solutions we offer to the market, we see also that the short sea shipping segments are also driving the environmental goals and work as a kind of a test bed for deep sea shipping. And a lot of the technology we apply in short sea shipping are also now being applied in deep sea shipping. And some of these solutions include electric charging and short connection, our onboard diesel grid platform, which is a platform where you can combine and connect different type of energy sources. And of course, batteries, and today's topic, fuel cells. One of the challenges we see in the maritime sector today is that it's a challenge to be compliant and meet increasingly strict environmental regulations, how to optimize the energy cost, and how to match the power loads and the power sources in the most efficient way. And also with more and more complicated hybrid power systems, we see a challenge to integrate multiple power systems. And what we are also addressing in this webinar today is how we can manage multiple energy types and consumers and make this as one simple system. Looking at what we see as a possible pathway to carbon-free shipping, we see many big shipping companies have their own goals, how to reach the carbon-free shipping within 2040 or 50. This is one possible pathway we see from ABB. And what we have been focusing on the last years is, of course, short connection, short charging to reduce emissions in port. Battery systems have been introduced to many types of vessels to reduce emissions. And at the same time, we're also working now with fuel cell demonstrator projects that we will talk about more today in this presentation. We see a next natural step for fuel cells is to have fuel cells to cover auxiliary loads and hot loads, and that can enable zero emission port call or port stay, or enter into a fjord, as an example, on zero emission. And at the same time, we are also working on scaling this up together with Ballard, that you will see today, that we are developing currently a megawatt scale fuel cell systems. One of the challenges we see in the market today is that the technology are maturing faster than the supply chain. So we're also looking into other type of energy carriers until we have a, let's say, a full-fledged supply chain of hydrogen. We also see that other energy carriers or hydrogen carriers, if you like ammonia, methanol, and synthetic fuels, are also good alternatives for reaching a carbon-free shipping. Some of the drivers we see in the market are, of course, the different emission regulations. These are both local emissions regulations and also the global regulations. And we clearly see a shift now in the focus from environmental emissions to a focus on the greenhouse gas emissions. But we also see that public opinion are in some cases even a stronger driver than the pure regulative drivers, and that shipping also need to turn the image to be environmental friendly. We see an increasing public concern about environment and the climate change, and that people are more aware of emission sources than ever before. And also that the younger generations are calling for action. So this is maybe even a stronger drivers, at least in some shipping segments, than the pure regulative drivers. Looking into the current and future compliant fuels, what is mostly used today is, of course, the fossil fuels, being HFO, MGO, and LNG. We also see that biofuels is used more and more, especially as a drop-in fuel that is mixed with the fossil fuel to reduce the carbon content. But going forward, we see challenges of having enough supply of biofuel to cover the need in shipping. What we see maybe as a more interesting long-term solution is fuel coming from renewables. And from renewables, you are producing hydrogen. Hydrogen can also be produced from fossil fuels. We see a lot of the oil majors like Equinor, Shell, and Total is looking into to produce hydrogen from fossil fuel using CO2 capture and produce so-called blue hydrogen. And from hydrogen, you can produce different type of synthetic fuels or so-called electrofuels. such as ammonia, synthetic diesel, electric methanol, and methane. But we see that the most efficient way to use the hydrogen is to use it directly in a fuel cell. But of course, for some vessels, based on the volumetric energy density of hydrogen, we can also look at other type of synthetic fuels as important energy carriers. But going forward, I think a main takeaway out of this is that we see hydrogen as a very important energy carrier, either to be used directly as a fuel on board or used as a basis to produce other carbon neutral or carbon free synthetic or electric fuels. Looking at the ship power plants, electric propulsion is commonly used in many vessel segments today. And we see an increasing trend to apply electric propulsion for a more efficient operation. And the way we integrate fuel cells and batteries today in combination with diesel gensets is shown in this example here, where we are combining 2 diesel gensets, 2 larger fuel cells, and the batteries in a hybrid power plant. What we see is that fuel cells are operating at high efficiency, and the life cycle cost is getting closer to combustion engines. In terms of fuel cell technologies, the 3 most promising fuel cell technologies we see at the moment is the PEM fuel cell that Dennis will talk about more today. And the PEM fuel cell is, that we say, the fuel cell which are available in scale commercially. This is also the type of fuel cell that is being applied in buses, cars, trains, and so on. We also see high temp PEM fuel cells as an interesting technology. Maybe not as mature available commercially as the low temp PEM fuel cells, but one advantage with high temp fuel cells is that you can have a higher system efficiency because of the higher exhaust temperature. Solid oxide fuel cells has also been used in the fuel cell industry for many years, mainly for stationary applications, and we see them also as an interesting technology going forward. But our main focus as of today, based on the I would say the technical maturity, is the low temp PEM fuel cells. The emissions are of course depending on the fuel being used. If you're using pure hydrogen, you basically get warm vapor coming out. If you use hydrocarbons as feedstock, you will still have CO2, but about 60 to 80% from what you have in a combustion engine. Looking at the efficiency of fuel cells have a higher efficiency compared to combustion engines. As you can see from the red curve, they have quite flat efficiency curves, and the efficiency is ranging between 60% at low load down to approximately 50% at max load. And as you can see, the curve is also quite flat and having a favorable operating area with highest efficiency at partial load, which is quite often where we operate our engines today. Looking at how this will be integrated to the vessel, this is simplified schematic drawing on how we are integrating fuel cells in the vessel's power and control systems. And in terms of control, the fuel cell comes with its own local control system. And in ABB, we have developed our own fuel cell control, which is interfaced to the overall vessel power and energy management system, as well as condition monitoring systems, automation, and safety systems. Electrically, this is integrated through a DC-DC converter. As the voltage on the fuel cells are varying with the load, we have typically a high voltage at low load, and as the load increases, the voltage drops. So we need a DC-DC converter to make the voltage stable, and if you have an onboard diesel grid system on board, this can be connected directly to the power grid on board the ship. If you have an AC system, however, you need to go through a DC to AC converter and a transformer, and then connect the switchboard to the fuel cell to the main switchboard, being a low voltage or medium voltage switchboard. A few words about storage. And we see different technologies being applied in shipping today. The first few vessels are going for compressed storage, and there are several different technologies available. This illustration shows a 40-foot container carrying about 1,000 kg of hydrogen. And we have looked at concept where it makes sense to use a containerized storage based on limited time for bunkering or limited infrastructure in port. And then you could replace empty container with full ones in port. We start to also see that liquefied storage systems are being applied. This example shows a tank from MAN Cryo, but we also see other companies like Chart Industries, Linde, etc., being now active in the marine market, offering liquefied hydrogen storage. We are also looking at how we can possibly produce hydrogen on board from other type of energy carriers, such as methanol and LNG. And in this illustration, you see an example from Freudenberg, which is a system with integrated methanol reformer and fuel cells. The local CO2 emissions may still be present, but can be CO2 neutral with bio or renewable fuel. In shipping, we are combining batteries and fuel cells. So in opposition to the car industry, where you see it's batteries or fuel cells, but in marine, we see that batteries and fuel cells are making a perfect combination. Batteries can be used to take the peak loads or the transient loads on the network, as well as supporting fuel cells in starting and stopping. The main systems we're offering in the market today is divided into two products. One is the small-scale systems, which is typically applied for power plants below 1 megawatt. In this concept, we are using commercially available fuel cell stacks, and this is put in a marine cabinet, as this example is showed here on the Ballard solution. This can be used for smaller vessels or for auxiliary power for larger vessels. At the same time, we're also developing the megawatt concept together with Ballard. And this example on this illustration to the right shows the 3 megawatt unit, which is a complete unit skid-based with the fuel cells and the balance of plant. And the main difference between these two solutions is that on the megawatt scale solutions, we are combining the balance of plant for several fuel cell stacks in order to optimize on cost and space. And the size of this is about a 40-foot container, quite comparable in volume if you compare an equally sized diesel engine with the genset. Safety is of course of highest importance in our engineering and R&D program for fuel cells. We are working with multidisciplinary workshops together with different maritime societies and classification societies in workshops in HACCP and HACCP studies. Instrumentation will be an important part of the safety, such as gas sensors and sensors for fire detection, and we're also applying safe design principles. At the same time, we're also working with DNV GL on approval in principle for the megawatt solution that we are currently developing with Ballard. Our fuel cell programs consist of several activities. Our own R&D project, which are mainly related to fuel cell powertrain, control and safety. And then we also are participating in several EU-funded projects, such as the Maranda and the flagship project. We also have a lab in Norway in partnership with Sintef Ocean. This is a hybrid power lab where we have diesel gensets, batteries and fuel cells, and we are testing out various power plant configurations. And then we are also, of course, working with a few customer projects ranging from a few hundred kilowatt up to tens of megawatt. We see that technology demonstrators and small-scale systems are already being delivered today, and also that the high power solutions are on the way. And some of the trends we see in shipping is that the typical first movers are small and coastal vessels, and also inland waterway vessels. And these are typically car ferries, fast passenger vessels, super yachts, and tugs. And these have either a hybrid power plant combining diesel and fuel cells, and some are also equipped with a fully fuel cell driven power plant. Then you also see the short sea shipping as an interesting segment overall, covering vessels such as RoPax, Ro-Ro, feeder container vessels, and short sea cargo vessels. And many of these concepts, we are looking at hybrid power plants combining batteries and fuel cells. And then we have the larger vessels, the deep sea vessels, and such as bulk carriers and containers, and also the larger cruise ships. For these vessels, we see a next natural step to use a fuel cell plant for the auxiliary load, but we also see that fuel cell combined with reformer solutions is a good fit for these applications, and you can use methanol or LNG as the main fuel on board. A few words about our references and demonstrated project that we are currently involved in. We did a project together with Hydrogenics back in 2017, testing out a 100 kilowatt system, which is a demo container used towards US Coast Guards and other bodies in US. We have also done a small pilot installation together with Royal Caribbean. And then we had the Miranda project, which is the EU-funded project that we are currently delivering system to these days. We also got a project in France last year together with partners in the flagship project. And in this project, we are installing 400 kilowatt fuel cell systems together with Ballard and other partners to be fitted into a river pusher vessel that will be operated in France in the Rhone River. And apart from that, we also see other solutions being now applied. We see fuel cells are both growing in size and also growing into several type of vessels. So with these slides, I conclude my presentations. Thank you for your attention.
Thank you so much, Stein, for an insightful presentation. And now we would like to ask our audience to participate in a short poll, which will appear on your screen in a moment. Launching it now. The question is, what needs to be in place to accelerate industry-wide adoption of fuel cell technology for vessels? And the options are more business cases, sustainable supply chains, high power capacity, and strong governmental backing. So please select one of the options and click on submit. And we will be sharing the results with you in a few moments. So here we go. Here are the results. Stein, may I please ask you to comment?
Yeah, indeed, interesting results to see that the stronger governmental support is indeed high score, and that's also what we see, that in order to get this technology going and also to trigger investments in this early stage, I see it's very important with governmental backing plans. Also to kind of unlock a chicken egg dilemma where we see investors in hydrogen production plants are waiting for the consumers, and the consumers are waiting for the supply chain. I think it's important to have this first mover support.
Yes, thank you, Stein, for the comment. And I would also like to ask our next speaker, Dennis Jensen from Ballard Power Systems, to comment on the poll results. Dennis?
Yes, of course. Thank you very much. Well, as you see that they're quite in my world equally important. The higher power capacity is of course something that we are very focused on, but having the the sustainable supply chain and stronger government backing is actually what we need to get going and see more applications.
Thank you so much, Dennis. And with that, the screen is all yours.
All right. Yes. I'll see if I can get this going. Oops. Okay. Thank you very much, Margrethe. Good afternoon, everybody. I'm very excited to get the opportunity to share some information on what Ballard is working on within the marine market. Just to give you a quick overview of what is going on today and our main focus right now is propulsion for ferries and barges and fishing vessels. We're also looking into hotel and auxiliary loads, heat and power for cruise ships. And whenever there's market need for longer range and quick refueling, is also in our favor. Of course, low noise, low vibration, no local or global emissions is also a key thing for fuel cells. And we are able to scale from 200 kilowatts to megawatt. So that's kind of the bulk of the work that we are doing today. Not everybody is familiar with Ballard, so I just wanted to make a quick introduction of our company. We're plus 40 years old, roughly 1,000 employees globally, very heavy on IP and publicly listed. Our main market is within mobility, so buses, trucks, forklifts, and other material handling equipment, and we are looking into trains and now also the marine market. We have more than 20 years of heavy-duty modules experience in the field, and with over 30,000 hours of operation. So all of that knowledge, and backed up by a lot of technology from the automotive world, all that knowledge is condensed into what we can deliver into the marine market. Last year, we announced that Ballard Center of Excellence is going to be in Hobro in Denmark. We're very proud of that. We are a proud maritime country in Denmark with a lot of the biggest shipping companies and a lot of suppliers within the marine market space. But also, as you might have seen yesterday, now we're going into making green hydrogen out of the Copenhagen area. So very excited about that. A lot of good trends is going on in the market right now. We are not alone. It's for us. It's a great pleasure to be among all these industry leaders in this business area. I'm not going to go through them all. You probably all recognize them, but we are very fortunate to have a very good collaboration and partnerships with all these different businesses. A little more into the fuel cell technology. So we are working on with the 8th generation of PEM, low temperature PEM fuel cells, with more than 1 million man hours of experience put into the design and more than $1 billion US invested into the technology. So what we have today here is the 8th generation liquid cool stack with zero emission. It's a solid state generator, no moving parts. It's very high efficient, and it has a high recyclability of the raw materials. It's low maintenance, long life, and can be refurbished. We can scale this into the multi-megawatt area. When we started out in the marine business, we've been spending quite some time trying to understand what are the market needs for a system that will work for most of our customers. So the voice of the customers was very important to us. We traveled around and visited a lot of different operators, system integrators, and also shipyards. Among this, we get a lot of feedback from all the partnerships we have in the funded projects that we're working on, which we are extremely happy about. All that we condensed into a requirement specification for the module that you see in this drawing here, and as Justin showed earlier. One of the things that we decided very early on is that we want to have a type-approved system. So we worked closely with DNVGL and it's a big effort for all of us, and we are very determined to do this. The system has to be simple to integrate, hence the type approved, but also the envelope size, and it needs to be integrated like already well-known components, like the connectors and like the cooling system and all that. We're going to make a system that also you can use as the redundancy in the fuel cell. So you have the ability to locate them close together or to separate them in the vessel wherever it makes sense. It has to be easy to service. It has to have a high power density, and the remote diagnostics is important. So we know that from the bus world, and for us, it's absolutely key to make sure that we have a healthy working fuel cell system. So when we look at the timeline, you see here that we are going for the type approval this year, later on this year, and already in 2021, in the later part of that year, we're going for a general availability on this product, meaning that if you have a project and you see that you're going to need those units, that's where we can start to manufacture and actually ship products. So what did we end up with? So here you see a much clearer picture of the module. It's going to be baptized FC Wave. Unfortunately, I can't give you a lot of data because the product release is not until September, but please feel free to connect with us again and join us for that release later on. But just some highlights on what we design. All connections are located in the bottom of the system. This means that when you integrate it in your vessel, you're able to make a false floor and not interface or not to step on all the connections all the time. We also did this modular design so you can see them standing next to each other on the picture below. So we require as minimum space as possible, or the footprint of the unit is as small as possible. So the height is determining that, and we are trying to squeeze all that in within a very narrow envelope. So when you all get to see the unit, you would recognize that it's extremely compact and designed for utilizing the minimum space as possible. We access all the interfaces from the front, meaning that you open up the cabinet doors and then you can actually get to whatever you need to service. It will be type approved. We're working very hard on this, and not only with DNVGL, but the Norwegian flag and especially Norlet is helping out a lot here. And I'm very confident that with this joint effort, we will succeed. One of the things that is key for us is when you install a Ballard FC Wave in your vessel, that we don't expand any requirements from the fuel cell to your vessel. So meaning that we all contain the requirements to the fuel cell, and even a thing like the cooling system is made for different type of water types, so you don't have to have any specific. There's not any specific requirements to your setup. Again, we're looking at the ease of installation here. Now, when we select the balance of plant components, one thing is important for us is we have all the knowledge from the buses and trucks, and we utilize the components that we know. This doesn't only give us a high confidence level in the quality, it also gives us the scalability and the economics of scale, so we also get cost effective. When we're looking at what kind of projects are we currently working on, as Stein mentioned, we're looking at a multi-megawatt system with ABB. We're working on the high seas project funded by EU. It's a Scottish ferry in the Auckland Islands. We are working on H2 ports, which is more material handling, but for port equipment. We're working in flagships, which will be 2 ferries, one in Norway and one in France, as mentioned earlier. And then on a project called Electra, which is a barge in Germany that you see, that's the green vessel below there. Ballard has currently 10 plus active marine projects, so it's a big chunk of our resources dedicated to marine, and we are all super excited about that, and we only see that growing in the future. A little more detail, actually you already saw this, but I just wanted to address some of the timeline here. We've done with the feasibility study, the approval in principle later this year, and then we will continue the work and eventually the implementation into a vessel. Ongoing, so what we will continue to focus on and where it's very important to us is this different synergies between our business areas. So when we're looking at multi-megawatt, it's go hand in hand with our distributed power generation power plants. So the balance of plant components for this is going to be key. Also, we will look and spend even more effort in how we certify our products. We will continue to join projects where we look into the availability of hydrogen, including liquid hydrogen. Also, how we store it, both internal and external bunkering. And as Justin mentioned, safety is absolutely key for us. We need to make sure that our products are safe and you can safely use your fuel cell power plant. That being said, we at Ballard stay committed to deliver fuel cell power for a sustainable planet. Thank you very much for listening.
Thank you, Dennis, for the insightful presentation. And now we would like to proceed to the Q&A part of this webinar. We have received many interesting questions from the audience today, so thank you everyone who has sent us questions. The first question is to Stein, and the question is it only possible to use a fuel cell on board in combination with batteries to deal with peaks?
No, I would say no, because we are also looking at using batteries and fuel cells in combination where you optimize the size of the power plant. And one typical example is that if you have, let's say, a short period of 1 or 2 hours that you need high power or peak power, this can be taken then from the battery, so you can, let's say, downsize the fuel cell plant and optimize on capex and energy use, and combining batteries and fuel cells in that way. So I would say yes, definitely batteries and fuel cells can be used in combination, not only with peak shaving, but also to optimize based on the vessel operation and use batteries for peak power in a longer period. Also add to that, if you have charging available in ports, you can charge up the batteries and then even have a longer duration of batteries and have fuel cells more for the continuous load. And you can also use the fuel cells to charge the batteries for periods you need higher power. Hope that was a good answer to the question.
Thank you so much, Stein. The next question, that's one for you as well. And we're getting quite a few questions about using fuel cells in combination with batteries. As you have now addressed. So that's clearly a topic of a lot of interest. But we're also getting a number of questions about considering ammonia with fuel cell.
Yes, I would say ammonia is also a very interesting fuel going forward. However, of course, challenges with ammonia is the high toxic level. And today there are no fuel cells that can go directly on ammonia, so you would need a reformer. But I would say indeed ammonia is an interesting fuel, and it's also interesting research going on to use ammonia directly in combustion engines. But to add to that, today you would need a reformer to crack out the nitrogen in order to use ammonia in fuel cells.
Stein, and the next question is related to hydrogen here. Can hydrogen be used as fuel for internal combustion engines?
Yes, that's also an alternative. There are also companies doing pilot testing and let's say the first pilot installations where you have a combustion engine running on hydrogen. So I'm sure we will also see that in the future. But of course, one of the advantages using the hydrogen in a fuel cell is that you will have a higher efficiency and you will have also less particle emissions, and then you will have in burning hydrogen a combustion engine.
Thank you, Stein. And the next question that would be for Dennis, and it's a very specific question. Is there a challenge when you parallel many fuel cell stacks or many fuel cell wave systems in relation to the resultant electrical isolation? How can this be addressed?
So we have a lot of experience on that, and we did design megawatt systems before with multi-array systems. So yes, there's a way you need to be careful when you do that design.
Thank you, Dennis. And the next question is for you, Stein. Is solid oxide fuel cell a good option for the larger ships, as you can use synthetic ammonia?
Yes, I would say solid oxide fuel cells is also indeed interesting. We have seen it mainly used in stationary applications now, but we also start to see the first pilot projects combining ammonia and solid oxide fuel cells. So I would say also solid oxide fuel cells can also be an application that is interesting especially for vessels where the volumetric energy density of hydrogen is a challenge. But of course, the downside is that you will have the conversion losses because ammonia is produced from hydrogen, so you will have conversion losses producing ammonia from hydrogen, and then of course crack it back to hydrogen in a solid oxide fuel cell. But indeed, there is also a very interesting solution.
Thank you, Stein. And the next question is to Dennis. What is the power, efficiency, and weight of one of Ballard fuel cell cabinets?
That's a good question. I would like to answer it, but if I can wait until the product launch, that will be great, because we would like to save all that information to later on. But great question. We will get back. We'll get back with that information.
Yes, absolutely. Thank you so much, Dennis. And then there is another question to you, Stein. Is this technology suitable for a 10,000 deadweight coastal ships with about 1,000 nautical miles one-way passage?
Yeah, that's a good question. Of course, talking about long distances, and we have to look at the operational profile. But of course, a challenge with long distance transits is to find space for storing hydrogen, which has a lower energy density than, for instance, LNG and of course diesel. So to say if it's possible or not, we need to study that further. But that will be very interesting to look at, and we could also then consider other type of hydrogen carriers, maybe combine that with the reformer and fuel cells.
Thank you, Stein. We also have a question about the recently announced Memorandum of Understanding with Hydrant France. And the question here is if you could tell us a little bit more details about this MOU. And you, Stein, if you don't mind starting, and then Dennis, if you could add from your perspective as well, that would be great.
Yeah, I can try to answer that. Hydrant France is a company based in Bordeaux in France, and they are focusing on larger fuel cell systems for power plants, typically for land-based industry. And they are also collaborating with Ballard on a multi-megawatt fuel cell system, the same as ABB is doing. and we see some possible synergies cooperating with them more into fabrication and production of our unit using their production facility.
Thank you, Stein. And Dennis, if you wouldn't mind saying a few words as well.
Yeah, of course. Actually, back to my presentation when I talk about megawatt in DG system, it's absolutely key for us to be a part of this and actually see the synergies between the different businesses. So we're very excited to be in this project as well.
Thank you, Dennis. And next question to you, Stein. How good are fuel cells in responding to fast dynamic load changes?
I would say fuel cells are quite fast. I mean, they are designed to be used on buses, trucks, and cars. Although a challenge is that they are slower than today's diesel combustion engines, but I would say on par or slightly better than today's LNG engines. So, of course, depending on the let's say response time you would need from the power plant and your operational profile, we would combine batteries with fuel cells so that the instant load increase is taken by batteries while the fuel cells are ramping up slowly. But as a rule of thumb, is roughly 1% load up time per second out of the full power.
Thank you, Stein. And the next question is to Dennis, and it's related to hydrogen safety. So is the hydrogen connection from the floor considered safe?
Yes, absolutely. Absolutely. We do work with the class societies about that and the flags, and we will make it safe. Yes.
Thank you, Dennis. And here is a question to you, Stein. What are the installation possibilities and or restrictions in terms of space on board?
I mean, looking at the fuel cells itself, they need to be installed in so-called fuel cell space or hydrant safe area. And this needs to be ventilated according to the safety principles and the guidelines by the classification societies. When it comes to the, let's say, balance of plant or auxiliaries to fuel cells, this can be placed in normal machinery space. In terms of storage solutions, tank systems, this is not our core business, but we have seen storage solutions both being placed on deck and also below deck with proper ventilation and safety measures, of course.
Thank you, Stein. And the next question is for Dennis. Could you please touch on the subject of maintenance requirements for fuel cells, such as lifetime, downtime, etc.?
So the way that the system is designed is to we come with a maintenance program. So there's some maintenance with some of the components that have different needs, and also the monitoring system will give us indications if anything pops up. It's very important to us that the operators of the vessels are able to locate and actually work on the modules if needed. So there's a whole program when we sell these units that comes along with it, where all the maintenance is described. So it's a long set of documents that will follow. So yes, we have all that details, and that will be a part of the supply from us.
Thank you, Dennis. And here's another interesting question to you, Stein. What is the possibility of retrofitting an older vessel with fuel cell technology?
Of course, this needs to be looked at on a case-to-case basis, but we see a lot of interest of retrofitting existing vessels with fuel cells. Fuel cells can be installed in a containerized solution, which makes retrofitting easier. And the same goes with storage. Storage is also available both in liquid storage and compressed storage in containerized solutions. So this is, of course, easing the retrofitting. And one of the examples I showed you in the presentation on the projects that we are doing is also actually a retrofit project, this Miranda project, where we are retrofitting the vessel with the fuel cells and batteries. So in most cases, it's possible.
Thank you, Stein. And Dennis, the next question is to you. It's about the heat emissions coming out of the fuel cell box. And the question is if, I'm just scrolling through, if the room needs to be treated specifically with dedicated air conditioner.
Yeah, so the unit will have its own filters, but the room needs to be ventilated, and all those requirements is basically depending on how many units you have in your fuel cell room, and how that is all is situated close to each other. So, but our system has its own filter, so it will filter particles that are not good for the fuel cell. So there's no additional requirement of any specific filtering of the air. It just needs fresh air because we need the oxygen to create power.
Thank you so much. And here is a question that I would like to address to both you, Stein and Dennis. So, you, Stein, if you don't mind going first, it's a question from public sector on how public procurement best can be made for smaller passenger traffic to include also fuel cells, and in this case, specifically hydrogen. All the different climate-free alternatives require quite a lot of investment, and normally they need to be able to be covered during a procurement period of, say, 5 to 10 years. And the person asking this is wondering if you may have any comments on this.
Yeah, it's a good question. Maybe giving one example from what I've seen in some parts of the world, like example of Norway or Denmark and so on, where the public sector is making a scoreboard system. So let's say the owner or party winning the tender is not only competing on price, but also have scores with respect to emissions and so forth as well. So that could be maybe one example that there is a scorecard for the tendering process that are also stimulating new technologies and zero emission technologies.
Thank you, Stein. Would you please comment as well, Dennis? Yeah, we see the same thing, and it's well known from the bus market as well. So that there's this scorecard that you can actually get a higher score from going with low emission.
Thank you. And the next question is to you, Stein. How is bunkering compared to LNG?
I guess the question is related to bunkering time, where at least I'm guessing that. So bunkering time to bunker, for instance, liquid hydrogen compared to bunkering LNG, the bunker time is about the same, to my knowledge. I'm not an expert in bunkering, but that's what I've heard in several discussions. Of course, if the question is more related to bunkering availability, of course, hydrogen has a long way to go yet to be on par with the availability of LNG. But there's also interesting progress being made in investments in hydrogen production areas, bunkering facilities, and the infrastructure needed for bunkering.
Thank you, Stein. And then the next question is to Dennis. What is the typical estimated hydrogen mileage of the system?
Oh, that's a hard question to answer. It really depends on the system. So we do have a operating sweet spot for this for our units, and what I can here say is that if you if you have a vessel or you have some data today, connect with us and we can simulate the usage of hydrogen on this specific case, because it's very depending on how the system is set up.
Thank you. And here is another question to you, Stein. Any special expertise is needed for ship operating staff for vessels with fuel cells?
Yeah, that's a good question. Of course, training of the crew in terms of safe handling of hydrogen is, of course, a special competence which is needed. I would say when it comes to maintenance of fuel cells, which is quite limited, as Dennis mentioned, there is, I mean, you'll say the daily maintenance or the yearly maintenance is basically very, let's say, basic maintenance in terms of cleaning filters and so on. Yeah, I would say the most competence build-up would need to be in safe handling of hydrogen, I would say.
Thank you, Stein. And we will only be able to address one more question during the session today, because unfortunately the time is running out. But what we will do is we will make sure to follow up with everyone individually after the webinar. So the last question today, and this I would like to address to both you, Stein, and Dennis. Geographically, Europe, and especially Northern Europe, seems to be driving the shift to low carbon shipping. And the question is there much activity happening in other regions of the world? Justin?
Yeah, I also I support that statement that you see a massive development happening in Europe, and especially northern part of Europe. But you also see very interesting development in Japan, for instance, South Korea, and China, where also there is quite large investments in both hydrogen and fuel cells, and also in alternative fuels. And of course, also we also see some. Sorry for interrupting. And of course, also US, we see interesting prospects and also some projects coming on the water quite soon in the US West Coast as well.
Yeah, we see the same thing. We get inquiries from all the way from Australia to a lot of North America. So I support that. It is northern part of Europe that is in the lead, but there's a lot of interest globally.
Thank you, Dennis. And with that, we have now come to the end of today's ABB TechTalks webinar. Thank you, Stein Vågen and Dennis Jensen, for sharing your insights about fuel cell technologies in shipping. And a big thank you to all our attendees for participating in today's webinar. We look forward to welcoming you again at the upcoming ABB TechTalks sessions.